I am Ramakrishna B N, e-content developer, digital learning, Department of Collegiate Education. I am going to explain for BSc Physics 5th Sem students, University of Mysore, stellar characteristics. It comes under astronomy and astrophysics paper. In this session of unit stellar characteristics, we are going to understand the evolution of a star to white dwarf stage through red giant stage. The learning objectives are concepts of evolution of star to white dwarf stage through red giant stage. The students must be able to understand the learning objectives. So now first we will understand what are red giant. A red giant is a luminous giant star of low or intermediate mass in a late phase of stellar evolution. The outer atmosphere is inflated and genus, making the radius large and the surface temperature around 5000 Kelvin or lower. When a star becomes a red giant, it will start to expand and become denser. It will then start burning helium to carbon for a couple of million of years until eventually the helium runs out. See, to explain the red giant, you can see the HR diagram, absolute magnitude versus surface temperature. You can see the variation as the temperature increasing, how the absolute magnitude is keep on increasing. Absolute magnitude or luminosity is increasing as temperature increases. For different spectral lines O, B, A, F, G, K, M, you can see the variation in absolute magnitude and the variation of luminosity of a star with the variation of surface temperature of the stars. You can see there are different stages of stars. Red giants, red supergiants, main sequence, white dwarfs, and different stages of stars shown in this graph. See, now we'll discuss what are the examples of a red giant star. A red giant star is a type of star that has exhausted the primary supply of hydrogen fuel at its core and is now using another element such as helium as the fuel for its energy producing thermonuclear fusion reaction. The star Aldebaran bullseye is the constellation Taurus is an example of a red giant star. How does a star become a red giant? See, the explanation for how the star become a red giant or when star first begin to fuse hydrogen to helium, they lie on the zero age main sequence. The core of a red giant is contracting, but The outer layer are expanding as a result of hydrogen fusion in a shell. How does a star become a red giant? See, when stars first begin to fuse hydrogen to helium, they lie on the zero age main sequence. The core of a red giant is contracting, but the outer layer are expanding as a result of hydrogen fusion in a shell outside the core. The star gets larger, redder, and more luminous as it expands and cools. Now, white dwarf. What are white dwarfs? See, white dwarfs evolve from stars with an initial mass of up to 3 or 4 solar masses, or even possibly higher. After quiescent phases of hydrogen and helium burning in its core, separated by a first red giant phase, the star becomes a red giant for a second time. Now we'll discuss about how red giant star converted into a white dwarf. Star less than about 10 times the mass. If the sun become asymptotic giant, branch stars, red giants with inert degenerate carbon oxygen cores. Degenerate carbon or oxygen cores that fuse helium in the shell around the core. If the remaining core is less than about 1.4 times the mass of the sun, then it becomes a white dwarf. Now, white dwarf stars and its evolutionary stage. See, what are white dwarfs? A white dwarf is what stars like the sun become after they have exhausted their nuclear fuel. Near the end of its nuclear burning stage, this type of star expels most of its outer material, creating a planetary nebula. Only the hard core of the star remains. The stages of a star after the red giant means what are the different stages of a star when the star become a red giant. In the core of the red giant, helium fuses into carbon. All stars evolve the same way up to the red giant phase. The amount of mass of a star as determines which of the following life cycle paths it will take from there. The life cycle of a low mass star or left oval and a high mass star or high oval. The references for these concepts are shown here. Thank you very much.